In this video, we want to find the area of the region that's bounded by the graph of this function, y equal x, square root of x plus 1, and y equals 0, the line y equals 0, which is the x-axis. So if we don't need the exact graph of this region, we simply need to know the region that's bounded. So notice here we have a radical, square root of a negative is not defined. We know that x plus 1 should be greater than or equal to 0, which means that x has to be greater than or equal to negative 1. So notice that if x is positive, this of course obviously is going to be positive. The graph is going to stay above the x-axis. Between negative 1 and 0, that's where the graph starts. Well, let's find the points of intersection of this function and the line. We simply set both of these equal to 0. So we have the product equals 0, which means x can be 0, or the square root of x plus 1 has to be 0. If I square both sides, I get x plus 1 is equal to 0, which means x is equal to negative 1. So notice if I replace the x by negative 1 into the function, I get negative 1 here, and then negative 1 and 1 is 0, square root of 0 is 0, so the y value is 0. The one point of intersection with the function and line is negative 1, 0. And then if x is equal to 0, replace the x by 0 in the function here, get 0 there, and then 0 and 1 is 1, square root of 1 is 1, times 0 is 0. So the points of intersection of the graph of the function and the line are minus 1, 0, and 0, 0. And notice that if I pick a number between 0 and 1, say negative 1/2, negative 1/2 outside, negative 1/2, and 1 under the radical is 1/2. Square root of 1/2 is positive. So between 0 and 1, the graph stays, or should I say between negative 1 and 0, the graph stays below the x-axis. So the graph is going to look something like this. Got to stay to the right of negative 1. It passes through 0, 0. So the bounded region is right here. That's the area we're looking for. Enclosed or bounded by the graph and the line y equals 0, which is the x-axis. So you simply set up the integral from negative 1 to 0 of this function. And could be several ways to evaluate the integral. I'm going to use the u substitution here. Let u equal to x plus 1. So du, we equal to the root of x plus 1 is 1. That'll be dx. And then from this here, I can solve for x, and I get x is equal to u minus 1. Now here's what we can do. We can go ahead and evaluate this and go find the antiderivative of this product x, square root of x plus 1, and then evaluate from negative 1 to 0, and we get the area of this region. Or we could leave it in terms of u and change the limits. Just as a change of pace, that's what we'll do. So I'm going to say, instead of negative 1 here, these are limits, x equal negative 1 to x equals 0. So if x is equal to negative 1, notice over here, in this right here, u would be 0. So this would be 0 here. Now, if x is 0, go back over here, this will be 1. So I'm going to change the limits from negative 1 to 0 to 0, 1. So here are the new limits, and here's my substitution. So now I have the limits from 0 to 1, and this is going to be transformed to u, the variable u instead of x. 0 to 1, the substitution x is u minus 1, and x plus 1 is u, and instead of a radical, I'm going to use fractional exponent 1/2. This would be u. And then we just multiply through. Oh, the other thing I might mention, because the region falls below the x-axis, if I just evaluate this integral the way it is, the answer is going to be negative. But I want a positive value because I'm dealing with area, so just put a negative out here. This then is going to be a negative there, u to the 1, and then multiply by u to the 1/2. U to the 1/2 times u to the first power is u to the 3/2 power. And then this will be minus u. U to the 1/2 times negative 1 is minus u to the 1/2. Now we have a basic integration using the power rule for integrals. U to the minus 1/2 there. And we're going to integrate here. Add 1 to the 3/2. That'll give me a 5/2. Then divide by 5/2 here, so that'll give me a 2/5 here. This will be minus. Add 1 to the 1/2. This will give 3/2. Add u to the 3/2. And in front, divide by the 3/2. I get 2/3 here. And the limits of integration are going to go from 0 to 1. And now start it over here. equals 2. So replace the u by 1 here. Again, I'll leave the minus out here. 1 to any power is going to give me 1. So for the first term there, that's just going to give me 2/5. And it's minus. Again, replacing the 1, the u by 1. 1 to the 3/2 is a 1 times the minus 2/3. It's still minus 2/3. And then it's minus the value at 0. So putting 0 where the u is there, that'll be 0 to the 5/2 is 0. Over here, u to the 3/2, and u is 0, that's 0. So this is going to be 0. So this is minus. Common denominator is going to be 15 here, so we'll multiply 2 by 3 here. This is going to be 6 over 15. Multiply the other one here by 5 to get the common denominator, so it'll be 10 on top over 15. So 6 minus 10 over 15 is a minus 4 over 15. And times the negative, we get a positive area, 4 over 15. So the area of the region bounded by the function and the x-axis is 4 over 15 square units. Now I could have transformed everything back to x and used the original limits from -1 to 0, and it would still work out. Thanks for watching, and we'll see you next time.